As a pillar of modern manufacturing, the efficient operation of CNC machine tools is crucial. However, given the complex mechanical, electrical, and software issues that can arise, quickly and accurately identifying and resolving faults is a critical skill for every technician. Welcome to the mini-lecture on intelligent equipment fault diagnosis and maintenance. With the extended use of CNC machine tools, various fault issues may arise. Today, we will focus on the classification of CNC machine tool faults and preliminary diagnostic methods. Before we begin, think about the ways we can classify faults in CNC machine tools. First, let's analyze the overview of fault classification. CNC machine tool faults can generally be categorized into four main types based on their nature and manifestation. 1. Mechanical faults involve the mechanical components of the machine tool, such as spindle, guideways, ball screws, and tool magazines, and may include issues like wear, deformation, or damage. 2. Electrical faults include damage or connection issues with electrical components such as circuit boards, drivers, power supplies, sensors, and motors. 3. Control faults related to the CNC system, including program errors, system software crashes, and communication failures. 4. Hydraulic and pneumatic faults affect the hydraulic and pneumatic systems, such as pump, valve, and pipe leaks or blockages. Now, let's classify faults based on their causes. 1. Human errors, typically caused by improper operation, maintenance, or programming errors. For example, incorrect operation might lead to machine collisions or overloads, and inadequate maintenance might exacerbate component wear. 2. Equipment failures refer to faults due to damage or aging of the machine's own components, often related to the machine's age, operating environment, and load conditions. 3. Environmental failures result from external environmental factors such as power grid fluctuations, excessively high or low temperatures, or high humidity, which can affect the machine's normal operation and stability. Next, we classify faults by their manifestation. 1. Sudden failures. These occur suddenly during normal operation, such as motor burnout or short circuits. Such faults typically cause immediate machine stoppage and require urgent repair. 2. Progressive failures. These involve a gradual decline in machine performance or functionality, such as bearing wear or decreased accuracy of guideways. These faults usually do not cause immediate machine stoppage, but affect machining precision and efficiency over time. 3. Intermittent failures. These occur sporadically during operation, such as unstable control systems or abnormal sensor signals. These faults can be challenging to diagnose, but still impact the machine's normal operation. By now, you should have a deeper understanding of CNC machine tool fault classification. Next, let's learn about the steps for fault diagnosis. When faced with faults in CNC machine tools, follow these preliminary diagnostic steps. 1. Observation. Start by recording the fault symptoms, such as alarm messages, unusual noises, or abnormal actions. This is the primary data for diagnosis. 2. Fault localization. Based on the fault symptoms and the machine's structure and working principles, make a preliminary judgment on the likely fault area. For instance, if an alarm code points to the electrical system, focus on checking the electrical components. 3. Data collection and testing. Use the machine's built-in diagnostic functions, such as self-check programs, parameter viewing, and fault logs, or employ tools like multimeters and oscilloscopes to measure and verify your hypotheses. 4. Step-by-step elimination. If direct localization is difficult, use a step-by-step elimination method, starting with the most common faults or the most easily checkable parts to gradually narrow down the issue. 5. Repair and verification. Once the fault cause is identified, proceed with repairs or component replacement, Then restart the machine and verify if the fault is resolved. Observe the machine's operation over a period to ensure stability. Finally, let's analyze two typical fault cases. Case 1. Spindle not rotating. Possible causes include electrical drive faults, spindle motor damage, loose spindle and coder connections, or system setting errors. During diagnosis, first check the spindle motor power supply lines and driver status, then inspect the encoder signals. Case 2. Tool magazine tool change failure. Common causes are mechanical jams, electrical control faults, or program errors. Start by checking for any obstructions in the tool magazine's mechanical parts, then inspect the tool magazine motor and position sensors, and finally review the tool change program. Maintenance is a discipline that requires both theoretical knowledge and practical experience. Through this lesson, I hope you will master the methods of classifying CNC machine tool faults and the diagnostic processes, continuously accumulate experience, and effectively solve complex problems in your work. Please remember, safety always comes first. Please adhere to safety rules during operation to ensure both personal and equipment safety. This concludes today's lesson. Please review and consolidate the material after class and complete the following exercises. See you in the next session.